All right, it's Volcano Week. It's some really cool stuff this week. Well, the really hot stuff, but very cool to talk about. Volcanoes, there are several different types. We're going to talk about the types of volcanoes. We're going to talk about what they do to the environment. We're going to talk about how they changed the Earth before life even existed. All kinds of cool stuff you can talk about when we talk about volcanoes. So way back when the Earth was just a billion years old, it started to turn solid, but then there was still heat built up in the inside, and more heat being made by nuclear breakdown of nuclear materials, and so that heat had to escape. And so because there was a solid surface, the crust had already formed, it needed a vent to get that heat out, and that's when volcanoes were created for the first time. It does not just vent liquid rock. It does not just vent lava and magma. It vents gases, liquid rock, and solid rock. And so there's different types of things that come out of volcanoes. We're going to talk about that too. Before life, the atmosphere was nothing. There wasn't an atmosphere. Then carbon monoxide, methane, nitrogen, not a good environment for life that's on planet Earth now. But back then, it was all we had. And then volcanoes started going off, and they released water vapor trapped inside the Earth. That plus comets colliding with the Earth brought enough water to make this a water planet. 3/4, 75% of the Earth covered in water. Some of it came from the volcano, some of it came from comets. And so the early atmosphere was heavily modified by volcanoes. Without all of that, no life on Earth. Without volcanoes, without something to get oxygen and, not oxygen, I am so sorry, not oxygen. Without something to get water and other gases out of the ground into the atmosphere, there would have never have ever been any life. There's other things that come out with the volcanic eruptions. You've got carbon dioxide, sulfur dioxide, or sulfate. Yeah, I'm gonna have to look that one up. I'm gonna write it up here. I'm gonna write the correct way to say it up there. It's methane gas, nitrogen, hydrogen, helium, all kinds of things venting into the atmosphere from the volcanoes. They were trapped in the rock because they were dissolved in the liquid Earth before it became partially solid. And so the early atmosphere was modified heavily by volcanic activity. Volcanoes have, what's a volcano? It's a natural opening, natural, not man-made. A natural opening in the Earth for venting heat and hot materials like magma and gases. Volcanic eruption, when solid, liquid, and gaseous particles erupt out of a vent in the Earth. We're going to talk about how the different volcanoes have different structures. The different structures are based on different chemistry. Some volcanoes have a basaltic chemistry, some have a granitic chemistry, and some have an andesitic chemistry. Andesite, granite, and basalt are three of our igneous rocks created by these different volcano types. These volcanoes, I'm going to give you a little brief rundown of where they occur, but we talked about subduction zones and seafloor spreading, the mid-ocean ridge, the plate tectonic boundaries. We talked a little bit about that before. We're in a little bit more detail now. The plate tectonic boundaries that are subduction zones, where slab pull is pulling the slab underneath and into the mantle and melting it again, create volcanoes, usually granitic volcanoes, usually granite-based chemistry in the lava and magma. Then there's divergent plate boundaries like the mid-ocean ridge, where the rifting occurs. Basaltic rock comes out of that, basaltic magma, basaltic lava, like the mid-ocean ridge at the bottom of the ocean. That's why oceanic crust is all made out of basalt. And continental crust is always on the subduction zones, so it's always made out of granite. Andesitic volcanoes, they're kind of halfway in between. It's a mixture of basaltic and granitic. You've got some quartz crystals in there, but you don't have as many quartz crystals and feldspar crystals as granite, and you don't have as much mica. But it's not all basalt either. It's andesitic. It's halfway in between. One flows very easily, basaltic granite. One flows very, very hardly, almost not at all. Granitic granite. And andesite is halfway in between. It flows kind of about half as well as basaltic granite. Basaltic magma. So these are not the only types of volcanoes you get, and those are not the only locations you get them. It's not just at divergent and convergent or subduction zone boundaries. There's also hotspot volcanism. Hawaii is famous for being a hotspot volcano in the middle of a tectonic plate. The Yellowstone calderas, there's twin calderas in the Yellowstone system, were mid-plate volcanoes. Those are not tectonic boundary volcanism. They're central plate volcanism. And Texas, Enchanted Rock, was in the middle of a plate in Texas, in the middle of the North American plate. Texas had a volcano almost. Enchanted Rock was going to be a volcano. It got real close to the surface. It moved up and up and up and up. It lifted the hill country 100 to 200 feet above the coastal plain of Texas. So where I'm at right now is 200 feet above the coastal plain. There's some hills that are even higher in the hill country here in Texas. The coastal plain's at 100 to 120 feet above sea level. Right here, 200 feet above sea level. A little bit north of here, 200, 250 feet above sea level. And so the hill country of Texas was all lifted up by it's called the Llano Uplift. It was lifted up by Enchanted Rock, but Enchanted Rock froze in the ground before erupting. No magma reached the surface. It froze in the ground. It crystallized before reaching the surface, so no volcano. An uplift zone, a long fault line from San Antonio all the way past Dallas, up into Oklahoma, called the Volcanoes Escarpment. It's a fault line that runs almost the entire length, almost the entire width of Texas. It stops just west of San Antonio in the Lake Medina area. So it could have been a volcano. We could have had a hotspot volcano here in Texas, but it didn't quite make it to the surface. It froze. And then the magma under it that didn't freeze pushed it up and up and up and made the Llano Uplift and made the hill country. So there's plate tectonic boundary volcanoes. California, South America, West Coast, the whole west coast of North and South America. China, Japan, Indonesia, the Philippines, the entire east coast of everything over on the side where China is, on the side of the Pacific where China is. All of that is subduction zone volcanism at convergent boundary volcanoes. And then the middle of the Atlantic is rifting, divergent zone volcanism. All kinds of different types of volcanoes come out of these things, but the basic types they're categorized in is basaltic, andesitic, and granitic. We already went over that. 3 types of volcanoes form from these different sites. Hawaii is shield volcanoes. Very basaltic, very shallow slopes that you can walk up it without climbing gear. Very wide mountain ranges. The biggest mountains on the earth are volcanoes, and the Hawaiian Islands are the biggest mountains, but you can't see them because they're all underwater. Mount Everest is 8,000 meters tall. Mauna Loa is 9,000 meters from the bottom of the ocean to the top of Mauna Loa, but you can't see most of it. It's all underwater, and you can just walk up it. You don't need climbing gear. Mount Everest, you have to have climbing gear, and like oxygen. It's ridiculous how to get up Everest. Mauna Loa is a bigger mountain. You can walk up Mauna Loa, but nobody's going to be impressed because it's not hard to climb. You can just walk right up it. So Mauna Loa, shield volcano, very low, flat volcanoes, very basaltic magma, very gentle eruptions. Yes, a 500-foot plume of magma is shooting out as lava. Very impressive. Really big, wide rivers of lava flowing down the mountains. Really impressive. Dangerous. You don't want your house in the way. But they're not dangerously explosive. They're not going to go boom and blow apart entire islands or parts of continents. They're just not going to do it. They're basaltic, very low viscosity, very low resistance to flow. Then that's the biggest mountains, the biggest volcanoes, but the gentlest eruptions from volcanoes. Then there's the composite cone volcanoes. I always say stratovolcano because that's the old word for it, and I grew up with that word. But it's a composite cone volcano. Now, a shield volcano, mostly lava. erupts out of it. Very little basaltic matter, very little solid matter, mostly liquid, mostly gases. It's time for class to end, kids. It's the end of the day now. So, stratovolcano or composite cone volcano can erupt lava or it can erupt solid matter. It always erupts gaseous matter, either way. Lava and gases or solids and gases. Either way, it is the second biggest type of volcano, and it can have different types of eruptions. Sometimes it's lava and solid matter and gases. Sometimes it's mostly lava, sometimes it's mostly gases, sometimes it's mostly solid. It just depends. The reason for that is it's granitic, it's granite, it's a magma that will mostly not flow very well. And so it's very high viscosity, very resistant to flowing. And so it kind of gets clogged up. If it's clogged up, it blasts a massive chunk of solid matter out as dust, dirt, lapilli is the small pebbles. Bombs are the chunks of rock about this big that turn into a roundish shape. They can be the size of a Volkswagen or a small house. They're called bombs. And then blocks, which are much bigger and rectangular, they can be the size of a large house. That's the pyroclastic explosions coming out of a stratovolcano or composite cone volcano. Pyroclastic explosions are house-sized blocks down to dust, and it's all solid. Sometimes there's lava mixed in with it. There's always gases mixed in with it. Or your composite cones can go off just a liquidy and gassy explosions. And then that's your medium-sized volcanoes on subduction zone plate boundaries, granitic magma. And then you've got your little volcanoes, the little cinder cone volcanoes, almost always solid matter coming out of those. Almost always pyroclastic. Lots of dust, lots of ash, lots of small bombs, lots of lapilli, pebbles. Sometimes some big boulders, sometimes some people-sized boulders, but they're only 300 feet tall. They're very small volcanoes. They're not tall at all. And so so three types of volcanoes: shield, composite cone, and cinder cone. Cinder cones are very explosive, but they're not big and deadly and dangerous. Your composite cones are the very, very dangerous, very, very explosive. You don't want to be near a stratovolcano when it goes off, a cinder cone or anything like that. All right, so is shield volcano, composite cone volcano, cinder cone volcano. I'm running out of time, so I'm trying to make sure I hit everything. Very gentle eruptions for shield cones, very, very, very dangerous eruptions for the medium-sized ones that are composite cones, and dangerous explosions coming out of cinder cones, but they're not as big. So they're not going to affect as large of an area. They are explosive. It is all pyroclastics, but not as big. I'm going to show you all pyroclastics in some videos, and lava flows in some videos. There's some very good videos out there, but I'll try and post up some pictures of it too on this video. What else before I'm done with this section? Because there's another, like if I do the PowerPoint, there's another 60 slides for this thing. This is going to be 2 videos. This might be even 2 days of teaching. Composites. Composite cone will have layers of lava, pyroclast, lava, pyroclast. It's going to be layered. It's going to have different types of eruptions at different times. Your andesitic volcanoes can be cinder cone or strato or composite cone. Very few shield volcanoes are andesitic. And then the shield volcanoes we don't see. The basaltic volcanoes we don't see. They're under the ocean, the mid-ocean ridge, where the Atlantic splits open, magma comes up, it makes new basaltic oceanic crust. Those are all underwater. We don't get to watch those go off very often. The entire Earth, almost the entire length of the Earth splits open, magma comes up, and it's not always, the whole length, but sometimes it's the northern part, sometimes it's the southern part, sometimes it's just tiny little sections of it. Those are basaltic. They're under the ocean. They make the oceanic crust. I'm going to talk about specific volcanoes next time. That's there's a lot of really cool, really fascinating eruptions. Mount Etna and Mount Mauna Loa always erupt. They're in the top 5 for constant eruptions. And then, of course, the ones in California and Washington State and South America, not as often. But we'll talk about more about that later. I think I'm going to wrap this one up and make a second video about... There's so much about volcanoes we could talk about. Volcanoes are so cool. I'll be back in another video.